record. Sorry, that's a shame. All right. Thank you. So yes, so I was saying we have to get rid of the log, so we're gonna apply exponential in the same base. Exponential, the same base. All right, to get rid of the log. Okay, so because my base is 5, so I'm gonna apply exponential in base 5. Okay, so here's my exponential in base 5, and then here's my equal. On the right side we have 1. So here it's gonna be 5 power 1. On the left side I have this whole log here. So this is gonna be 5 to the power. So this is 5 to the power. It's not 5 times. Okay, so it's 5 to the power. Log in base 5 of x minus 4 over x plus 3. All right. So we said the exponential and the log, they are inverse of each other, so they would cancel out. So this 5, this exponential base 5 and this log in base 5, they would cancel out, and so that would be just x minus 4. X minus 4 over x plus 3 equals to 5. Right? So we got this equation. So on the left side, it's a fraction, right? X minus 4 over x plus 3. On the right side, it's a whole number, but you can make the whole number looks like a fraction by dividing by 1. So here, this 5, I'm going to divide 5 by 1. Okay. So now we have like fractions on both sides. And then how do we solve the equation with fractions? So all you have to do is to cross multiply. So I'm going to cross multiply. And so you cross multiply. So that would be 1 times the x minus 4 equals to the 5 times the x plus 3. All right, so left side, it's just x minus 4. Right side, that's 5 times x, that's 5x, plus 5 times 3, that's 15. All right, and then we have to solve for x, of course. So then I'm going to just subtract x. So this is negative 4 equal to 4x plus 15. All right, and then I can subtract 15. So this is minus 15, both sides. So that's minus 19 equals to 4x, right? And then I'm going to just divide by 4. So this is here over 4 both sides, of course. So then my x would be just, negative 19 over 4. All right. Okay, so we are not done yet, guys, because there's another step, and there's another last step, which is remember, guys, we said we can only apply log on positive numbers, right? So if you have log in base 5 of x minus 4, so then this x minus 4 must be positive. Okay, this x minus 4, this number here, it must be positive. Okay, and the same for the x plus 3. The x plus 3 also must be positive. Okay, that's because we can only apply log on positive numbers. Okay, log of a negative number, it's undefined. It do not exist. Okay, it's like saying square root of negative numbers or dividing by 0 is undefined, right? The same for log. Log of negative number or a log of 0, it's just undefined. Okay, so the x minus 4 and the x plus 3, they must be positive. Okay, so last step would be to check the positivity condition. So this is step 4. So we have to check the positivity condition, right? So what I'm saying is that my both my x minus 4 and x plus 3 must be positive. Okay, so my x minus 4, so x minus 4 and x plus 3, they must be positive. All right, so I got this, I got this x equal to negative 19 over 4, right? So I have to check that for such value of x, if you subtract 4 or if you add plus 3, then it's positive, right? But then, of course, if you do now, if your x is 19, now my x is negative 19 over 4, right? So if you do x minus 4, that's negative 19 over 4 minus 4. Of course, it's going to be negative, right? So this is a negative 19 over 4 minus 16 over 4. So it's just minus 35 or negative 35 over 4, right? Which is negative. It is negative. Okay. It's not positive, right? It's negative. So then if it's not positive, so this is not positive, then we have to reject this solution negative 19 over 4. So this negative 19 over 4 is rejected. So the conclusion is negative 19 over 4 is rejected. Okay, so then find the answer. So the answer to the problem is that there is no solution. Actually, so the right answer here would be so there is no solution to the equation. Okay, because this negative 19 over 4, if you subtract 4, then it's going to be negative, and we are not allowed to have negative numbers inside the log, right? We cannot apply a log on negative numbers. Okay, so we have to reject the solution, and your answer must be it has to be no solution, right? In this case, so there's no solution. Any question, guys? All right, so here's an exercise. Okay, so please try to solve. Let's see, so log and base. Let's see, here's a base 5. So that's a log in base 3. All right, so log in base 3 of x plus 2 minus log in base 3 of x minus 4 equals to 2. All right. Okay, so let's say you have 5 minutes, guys, to think about this exercise. So please try to solve this equation, this logarithmic equation. So I guess after this, I mean, this is section 3.4, and then so we're going to be done with this chapter 3. So next, we're going to move to the chapter 4. For chapter 4 is about trig. trig functions. We have like just I would say one lecture on Wednesday, and probably I hope today I think I'm gonna start chapter 4 today, because there's only the exponential equations left. So I'm gonna probably do 1 or 2 examples, and then after that we can start chapter 4. So I'm gonna try to do my best to cover the most important notions in the chapter 4. There are a lot of things to cover actually, but I mean, we don't have time. um, anyway, we'll see how it goes. So again, for the second test, the test number 2, so the test is going to cover sections. So from section 2.3, that's 2.3, that's graphing polynomials, right? So 2.3 to 2.7, and then there's this chapter 3, which is basically solving exponential and logarithmic equations.
Professor,
Yes.
my question is about like checking the positivity of
So
uh,
the
the
solution.
last part.
Sorry, I didn't hear you.
My question is about the last part, checking
Mm-hmm.
the positivity of
Positivity of M.
yeah. So you took like x minus 4 to check it. You could took like x plus
3.
yeah.
Yeah, I mean, if one of them is not positive, then you have to reject the solution. So, if
Okay,
you yeah, if one of them is not positive, then you are done.
okay.
Mm-hmm.
I got it.
Mm-hmm.
Okay.
Crystal, you're saying X would be 10. Malik, you got 19 over 4. Um, I'm not sure actually, because I didn't solve the problem. I have to solve the problem first. I don't know the answer. Uh, but let's see. I would say, let's see. 2x. But I think 10 would make sense. I think 10 would be the correct answer. Um, I think so. So I think, Crystal, you're right. Malik, I don't think 19 over 4 would be the right answer. So I would say Crystal. Oh, you did something wrong, Crystal. Okay, okay. Then probably Malik is he has the correct answer. Again, guys, I'm sorry. I don't have the answer. I mean, I didn't solve the problem yet. So okay, then Carolina, you got also 19 over 4. So okay, so I guess 19 over 4 is the correct answer. Khadija, you're saying you're confused. So you're confused about what? What's the problem? So what's the problem? How did they get a 19 over 4? Yeah, I'm gonna go over the go over the exercise. Yeah, sure. Okay, so I guess 19 over 4 will be the right answer. Um, but then, guys, so you have to check that your solution is satisfies the positivity condition, right? So you need your solution plus 2 and your solution minus 4 to be positive. And of course, 19 over 4, I mean, that's 4.75, I think. So that would satisfy the positivity condition, I guess. Okay, guys. So let me. Okay, so I guess you're done with this exercise. So let me just. So I'm gonna go over the exercise. So first step, we said because it's a subtraction, we're gonna combine, of course, the two logs into one log. But because it's a subtraction, then we're gonna have a fraction, right? So that's a log in base 3 of x plus 2 over x minus 4. Okay, so again, guys, be careful in the test or in the final. If it's a minus, you're gonna have a fraction. If it's a plus, if you had a plus here instead of a minus, then you're gonna have x plus 2 times x minus 4. Okay, just be careful. All right, because otherwise, if you have a fraction instead of a product, then of course you would end up with a wrong answer, right? So just be careful. So that's a fraction because we have a subtraction. Now, second step would be to get rid of the log. So I'm gonna apply. So this is a log in base 3. So here's my 3. Here's my 3. Here's the equation. So on the right side I have 2. So that will be 3 square. And on the left side I have this log in base 3, x plus 2 over x minus 4. So then this 3 and this log, they would cancel out. And so it's just now x, it's just x, oops, sorry, it's x plus 2 over x minus 4. On the right side, that's 3 square, of course, which is 3 times 3, and that will be 9. Now, I'm going to solve this equation, right? So I'm going to make this 9 looks like a fraction, so that's 9 over 1. And so I'm going to just cross multiply, right? So then we have 9 times x minus 4 equals to 1 times x plus 2. So that would be 9x minus 36, and that's x plus 2 on the right side, right? So then we're going to subtract x minus x. So that's 8x minus 36 equals to 2. And then I'm going to add plus 36 both sides. So that's 8x equals to 38. All right, and then I'm gonna divide by 8, both sides, of course. So that's x. Oh yeah, okay, Crystal. Yeah, it's 3 squared. Yeah. So you have to apply the exponential for both sides, not just for the left side. So that's x equals to 38 over 8. You reduce a fraction, you have to reduce your fraction, guys. So this is, let's say, divisible. Both are even numbers, so I'm going to divide, let's say, by 2. And so that'll be 19 over 4. Okay. So yes, Malik, Carolina, you got the right answer. It's 19 over 4. Now, the last step, which is a very important step again, guys, because you could just reject the solution. So this is step number 4. So you need, in step number 4, so you come back to your initial equation, right? And as I said, you can only apply log on positive numbers. So which means that you're going to apply this log in base 3 on x plus 2. So my x plus 2 must be positive. And here you're going to apply this log in base 3 on x minus 4. So this minus x minus 4, it must be positive, right? So x plus 2 and x minus 4, they must be positive, right? So x plus 2. So x, oops. So x plus 2 and x minus 4, both, they must be positive. Both, right? Must be positive. So what's my x? What's my solution? My possible solution is 19 over 4. Okay, that's my x. So I have to check that. So we have to check that 19 over 4 That's my x, so 19 over 4 plus 2, and 19 over 4 minus 4. I have to check that both of them are positive, all right? So 19 over 4 plus 2, that's, of course, that would be positive because it's a sum of two positive numbers, so it's going to be positive, right? Now, what about 19 over 4 minus 4? 19 over 4, as I said, that will be 4.75, right? This is, I mean, 19 over 4, that's 4.75 minus 4, so that's 0.75, which is, of course, positive. Okay, so you see here in this case, guys, both are positive, so then this 19 over 4 would be a final solution. Okay, so then the answer x equal to 19 over 4 is the solution. All right. So again, both, they must be positive, the x plus 2 and the x minus 4. If one of them is not positive, then you have to reject the solution. All right, so that's for the exponential. Any question, guys? Khadija, too, you're still confused, or does it make sense now?
Yeah, it makes sense.
Okay,
Yeah, it
perfect.
does. Thank
Okay,
you.
perfect. Okay, perfect. All right, so let me now, guys, move to the exponential equations, right? So we are done with the logarithmic equations. I think we had plenty of examples. Now, let me just do one or two example, the exponential equations, and then we're gonna have an exercise, of course. So this exponential equations. So let me start with the first example. This is example number 1. All right, so in the exponential equations, guys, so let's say you have an example where you have the same base. So let's say you have 6 to the power x minus 1 equals to this to 6 to the power 2x plus 4. All right, so this is an exponential equation because so this left side here is this 6 to the power x minus 1. So this is an exponential function, right? This is an exponential, I mean, both of them are exponential functions, right? Because remember, guys, the definition of exponential function, that's when you have a constant to some power involving x, right? So this is exponential functions, right? Because well, it's because of the form a to the power x, right? So it's like you have a constant. So like here, the constant would be 6, right? To some power involving x, right? So there's an x in here in the power, right? There's an x here, there's an x in here. So both are exponential functions, okay? That's the definition of exponential function, right? So now, the thing is, so both sides, we have the same base, which is a base 6. So both are exponential functions with the same base. Okay, and so the base here is 6, right? That's our base. Now, guys, when we do an exponential equation with the same base on the left and the right side, so what you have to do is you have to apply log in the same base. So step 1, just apply the log using the same base. Okay, so what I'm gonna do, I'm gonna apply a log. So the base here again is 6, right? So I'm gonna apply a log in base 6 left side and a log in base 6 on the right side. So on the left side, we do have 6 to the power x minus 1, right? And on the right side, I do have 6 to the power 2x plus 4. Okay, so I applied the log in base 6 to both sides. Now the thing is, so why do we apply the log in both sides? Because remember, guys, when you apply a log to some, to like here, like 6 to the power x minus 1, so then you can bring down this this power here to the front of the log here. Okay, and this one here, this power, you can bring it down to the front of the log. Okay, so you're gonna have, that's because this is one of the property of the log. So let me just remind you. So if you have like a log of some log in base a of x to the power y. Okay, so if you have a log applied to x to the power y, then you can bring down this power y, this one here, to the power to the front of the log. So that would be y times log in base a of x. Okay, so if you have some power in the log, inside the log, then you can bring down the power in front of the log. Okay, so then my left side would be x minus 1. That's my power. That's my exponent. That's x minus 1. And then we are left with log in base 6 of 6. And then the left side, it's 2x plus 4 log in base 6 of 6. Okay. Now, the thing is, guys, this log in base 6 of 6, that's equal to 1, right? Because we said log in base a of a, that's always equal to 1. Okay, so this is one of the property of the log. So let me just remind you. So if you have a log in base a of a, so we have the same base. So it's a log in base a of a. That's always equal to 1. Okay, always equal to 1. So like here, this log in base 6 of 6, this is equal to 1. And this log in base 6 of 6 is also equal to 1. Right? So this is, now it's just, it's just x minus 1 equals to x plus 4. So now it's just, it's x minus 1 times 1 equals to the 2x plus 4 times 1, right? In other words, it's just x minus 1 equals to 2x plus 4. All right. And then, of course, you can solve for x. So it's just, subtract x. This is negative 1. This is x plus 4. And then you can subtract, 4, subtract 4. So yeah, then left side will be negative 5, or right side will be just x. Right, so then your solution is x equal to negative 5. All right, and that will be actually the final answer, because for the exponential functions, guys, the domain is the whole number line. So there are no restrictions on the domain of exponential functions. So what I'm saying is, so you see here in the original equation, you have this 6 to the power x minus 1. So your x, this x here, it could be any number. It could be positive, negative, it doesn't matter. Okay, so your x could be any real number. So there are no restrictions on exponential functions, right? The domain would be any real number. So that's why here there's no condition to check. So then you can just say the final answer. So final answer is x equal to negative 5. All right, so then x is equal to negative 5. Okay. So in this example, you know, in this example, we had the same base, right? It's 6 to the power x minus 1 equals to 6 to the power 2x plus 4. So we have the same base, right? And actually it makes sense, right? Because you know, if you have the same base, it means that like the powers are equal. So the x minus 1, the power or the exponent x minus 1 is supposed to be equal to the exponent 2x plus 4, right? And that's what actually we got, right? That's exactly what we are saying here. We have the same base. If you have the same exponential function with the same base, then actually, you know, the exponents, they're gonna be equal, right? Now, in the example number 2, I'm gonna have different bases. So this is example number 2. Now I'm gonna change a little bit the equation. So I'm gonna say, let's say 4 to the power 2x minus 1 equals to 3 to the power x plus 2. Right? So this example is different from, again, it's different from the previous one because now we have exponential functions, but with different bases, right? Here it's base 4. This is a base 4. Okay, and this is base 3, right? So we have two different exponential functions with different bases, right? This is base 3, right? So that's different from our previous example because in the previous example, we had both sides, we had the exponential function of the same base, which is base 6, right? So now, so how do we solve such an equation when we have different bases, right? So the idea is because the bases are the bases are different. So we're gonna apply a natural log. So in this case, when you have step 1. So when we have different bases, we apply natural log. So let me just remind you, natural log, that's the log in base e, right? We talk about this special number e, which is 2.71, etc., right? And so this log in base e, it's called, again, it's called natural log. So this is ln, and that's what I call natural log. Okay? Natural log, ln. Okay, so when you have different bases, then we apply natural log to both sides. Okay, because natural log, it's like a kind of the most common logarithmic equation we use. Okay, so we apply natural log both sides. So here's my natural log, and that's, again, it's a log in base e. So natural log left side, natural log the right side. Okay, so left side, we do have 4 to the power 2x minus 1, and the right side, we have 3 to the power x plus 2. All right, so then the idea next is the same. We can bring down this power here to x minus 1 to the front of the log. The same for the x plus 2 to the front of the log. So we're gonna have 2x minus 1 times natural log of 4 equals to the x plus 2 times natural log of 3. Okay. Now, guys, you need to think of this. I mean, this natural log of this natural log of 4, it's just some number, right? So, I mean, if you have a calculator, there's a natural log in your button in your calculator, so you can just compute this number, natural log of 4. So it's just it's just some number. I think it's 2 point something or right. So this natural log of 4, you have to think of it as just a number, right? The same for natural log of 3. It's just a number. All right, but it's gonna be a decimal. So if you use a calculator, then your natural log of 4 would be like, I don't know, 2.21134, whatever, right? So it's going to be a very long decimal, right? So instead of using the decimal in your equation, we're going to just keep the natural log of 4 or natural log of 3, right? So anyway, so I'm gonna deal with this natural log of 4 and natural log of 3 as just numbers, right? So then left side, you're gonna have this, this 2x times natural log of 4. So there'll be 2 times natural log of 4 times x, all right? So that's what you get when you multiply this by natural log of 4. And then there's minus, sorry. Okay, probably I should mute this. All right, so then, and then there's minus 1 times natural log of 4. Okay, the same on the left side. I have this number, natural log of 3 times x. So that's equal to natural log of 3 times x. Again, guys, think of a natural log of 3 as a number. It's like saying 1.7 times x, all right? Or something. So it's just a number. Okay, don't get scared of this natural log of 3 or 4, okay? And then next, there's this 2 times natural log of 3, so it's plus 2 times natural log of 3. Right? I want to solve for x. Okay, so what we do is, of course, I'm gonna just first subtract the x here. I have natural log of 3 times x. So I'm gonna subtract natural log of 3 times x minus natural log of 3 times x. Okay, so that's equal to so on the left side, I have 2 times natural log of 4 times x minus natural log of 3 times x minus 1 times natural log of 4. 1 times any number would be the same number. So it's natural log of 4. And the left side, right side, this is canceled out here. So it's just now 2 natural log of 3. Now, so you see here, there's an x in here, there's an x in here. I can factor out the x, but before factoring out the factor out x, I'm gonna add here. This is minus natural log of 4, so I'm gonna add plus natural log of 4 both sides. Natural log of 4. So then minus natural log of 4 plus natural log of 4, they would cancel out. So this is just equal to, so we have 2 times natural log of 4 times x minus natural log of 3 times x. And then on the right side, it's 2 times natural log of 3. So it's like, say, 2 times 1.753, etc. Okay, it's just some decimal, right? Plus another decimal, which is natural log of 4. Now, left side, I can factor out x. It's a common factor. Factor out x, so it's x times 2 natural log of 4 minus, this is minus here, the natural log of 3. And the right side, it's 2 natural log of 3 plus natural log of 4. Okay, so I factor out x, so then I can divide both sides by this, this 2 natural log of 4 minus natural log of 3. And the same, of course, you have to do the same on the right side, 2 natural log of 4 minus natural log of 3. So then on the left side, this, this 2 natural log of 4 minus natural log of 3 cancel out. So then your x would be just, so then your solution, your x would be 2 times some decimal, natural log of 3 plus another decimal, which is natural log of 4, over 2 times another decimal, natural log of 4 minus this natural log of 3. And that would be a fine answer, actually. All right. And as I said, there's no condition here to check because, you know, as I said, exponential functions, they're defined for any real number, x. So there are no restrictions on x, right? No conditions on x. It can be any real number. It doesn't have to be positive or negative or anything, okay? It's not like for log. All right, so that's a fine answer, guys. And again, as I said, don't be scared from this natural log of 3 or natural log of 4. It's just it represents a decimal, right? It's just some decimal, right? Any question, guys? So just again, so let me just repeat again. Here, there are two cases, like two different cases. The first case when you have an exponential equation where you do have the same base, right? Both sides, like here in my example, both sides of the base, same base, which is 6. So all you have to do is to apply the log using the same base, right? So then the conclusion is that the exponent that will be equal, right? But then there is the second case, which is more, I would say, more complicated, is when we have exponential functions with different bases, right? Here is the base 4, base 3, but then in that case, you have to apply natural log, okay? So when you have different bases, you apply natural log because that's like, natural log is like the very common log we use, all right? Anyway, no question, guys? So then here's an exercise. Okay, so we have to solve for x, of course. Solve for x. So first equation. So let's say you have this 5 to the power 2x minus 5 equals to 5 to the power minus x plus 2, right? Number 2, the first equation. Second equation is the following. So let's say you have 2 to the power x minus 1 equals to let's say 7 to the power minus 2x plus 3. Okay, this is a 7. All right, guys. Let's say you have 5 minutes to think about this exercise. So again, this chapter 3 is included in the test, which is next Monday. All right, guys. Well, any guess for the first one? What will be x for the first? What will be the solution for the first equation?
Five.
Excuse me.
5.
5. For the first equation, no, I don't think so.
First one, I believe, is 3.
Yes. First one, no. There's a no. It's not the. It's not possible. Yeah, 7. It's a 7/3 actually. It's 7/3. Yes. Yeah, just be careful, guys, because there's this minus here. All right, this is minus. So yeah, I think 7/3 is the correct answer.
Yes.
Just be careful of the minus x. Carolina, you're saying yes. I think your answer is correct. Yeah, absolutely. Very good. Yes. Yes, correct. I think it's correct. Absolutely. Mm-hmm. Yeah, just be careful, guys, on number 2. I mean, it's not. Um, all right. Sorry, guys. We don't have much time, so I have to go over this exercise very quickly. So yeah, for number 1, because we have the same base, then you apply this log in base 5 both sides. So then you will get an equation with the on the left side you have 2x minus 5, the exponent, right, equal to the exponent of the right side, which is minus x plus 2. And so you have to solve for x. So there's a plus x here, plus x, because it's a minus, so you need plus x both sides. So that's 3x minus 5 equals to 2. Then get rid of the minus 5, so plus 5. And so that's 3x equal to 7. And so your x, you divide by 3. So then your x would be 7/3. right? So just be careful of the minus x. So if you have minus x, you're gonna need plus x, right? And again, the way I got this equation to x minus 5 equals to minus x plus 2, that's because I applied log in base 5 on both sides. And so the exponent, they're gonna be equal, right? Now for number 2, it's, as I said, it's different bases. So then you would we have to apply natural log for an example number 2. So I'm going to apply natural. So we have I have this 2 to the power x minus 1, and I have this 7 to the power negative 2x plus 3. So I'm going to apply natural log both sides. So here's my natural log, and here's my natural log. All right, and then so then the exponent, they I can bring them down here, here, and so we're gonna have x minus 1 times natural log of 2 equals to minus 2x plus 3 times natural log of 7. All right, and so you have to expand left side. So it's natural log of 2. It's just a decimal times x minus 1 times natural log of 2. So it's just natural log of 2. Right side, it's minus 2 times x times natural log of 7. So it's minus 2 times natural log of 7 times x. And then there's plus 3 times natural log of 7. Okay. This is minus, so I'm going to need a plus 2 times natural log of 7 times x. The same thing on the left side, plus 2 times natural log of 7 times x. So then on the left side, we're going to have natural log of 2 times x plus 2 times natural log of 7 times x. And then there's this minus natural log of 2. So here's my minus natural log of 2. On the right side, the right side, you have this, so this minus 2 natural log of 7 times x cancel out. So it's just, now we are left with the plus 3 times natural log of 7, right? So this one here, there's an x in here, there's an x in here. So I have to get rid of the natural log of 2. So this is plus natural log of 2. This is plus natural log of 2. So, right. So then this minus natural log of 2 plus natural log of 2 cancel out. And then, so you see that the idea is, of course, left side, I can factor out x, right? So then, I'm going to have natural log of 2 times x plus 2 times natural log of 7 times x. So x would be a common factor, and so I can factor out x, right? And then the right side, it's just this 3 natural log of 7. So it's just some number, some decimal plus another decimal, which is natural log of 2. Now, left side, I have x as a common factor, so I can factor out x. There's an x in here, an x in here. So factor out x times, and then there's this natural log of 2 plus, and here we have 2 natural log of 7. Right. The right side, the same thing. Natural log of 7 plus natural log of 2. And now I can divide, because I factor out x, so I can divide by this this whole thing here, natural log of 2 plus 2 natural log of 7. The same on the right side, it's natural log of 2 plus 2 natural log of 7, right? That's because now this natural log of 2 plus 2 natural log of 7 cancel out, so it's just now x on the left side. So I am left with x on the left side, just x. Left side, on the right side, I'm going to have this 3 natural log of 7 plus natural log of 2 over natural log of 2 plus 2 natural log of 7. And that will be, of course, that will be fine answer. All right. Any question, guys? Okay. Anyway, so and as I said, when we have an exponential equation, there are no conditions to check. So you are done, right? All right. So yeah, so we are done actually with this chapter 3. As I said, it's this chapter 3 is mainly about this exponential and logarithmic equations. As I said, we will have the last homework this week. And of course, in the homework, you're going to have exponential and logarithmic equations to solve. All right. Okay, guys. So now let me move to the next chapter, chapter 4. So this is chapter 4. All right. So of course, it's about trig functions. Okay. So I mean, the goal in this chapter 4 would be to study this trigonometric trig functions, right? The sine of x, cosine of x, etc. Right. So, but first, before the trigonometric functions, I'm gonna introduce the angles and how to measure angles, etc. Right. So first, let me start with the definition of an angle. Right. So what's an angle? An angle is just it's formed by 2 rays. So let me just write down here. So definition of an angle. So an angle is formed by, let's say, 2 sides or 2 rays. So an angle is formed by 2 rays that have a common vertex or endpoint, that have a common vertex or endpoint. Okay, so what I'm saying is that, so you have this, you have this vertex, and there are 2 sides. So the first, let's say there's this first side here. So the first side is called the initial side. So this is your, let's say this is your initial side. All right. And then there's a second side, which is, let's say, the terminal side. This is here, there's a terminal side. Okay. And so when you go from the initial side to the terminal side, you form an angle, right? So then you go from the initial side to the terminal side. Okay, you get an angle. So there's an angle here, angle, let's say angle theta. Okay. So that's what I mean by an angle, right? So you have a vertex, or you have a vertex, and they have 2 sides. There's an initial side and terminal side. And when you go from initial side to the terminal side, you get your angle, right? That's what I call an angle, right? And of course, there are 2 possible, there are 2 possible rotations. If you go clockwise or counterclockwise, so there are 2 possible rotations. So if you go counterclockwise, so first, let's say you go counterclockwise rotation. So for example, let's say you have this angle here, So let's say you go from, this is your initial side, and you go to this terminal side, right? This is your initial here, initial side. Here's your terminal side. All right, so you have a counterclockwise rotation, then your angle theta, so the angle you get is actually a positive angle. Okay, so then in this case, theta, the angle theta is positive. Okay, now if you have a clockwise rotation, so if you go, so let's say you have a clockwise rotation, and you go from, so let's say this is now your initial side, and this one is your terminal side. So this is your initial, and here's your terminal side. So you go from the initial to the terminal side, right? So you get a clockwise, a clockwise rotation, then you get a negative angle. So then that will be a negative angle. So this is your angle theta. So in this case, the angle theta is negative. So what we have to keep in mind, guys, is that your angle, an angle, it could be positive or negative, okay? Okay, so now, so how do we measure angles? So which units we use to measure angles? Well, there are two different main units. Two units to measure angles. You have degrees, and you have, of course, radians, right? So there are, you want to measure angles, right? So measuring angles. All right, so then, so there are two units you can use. So we can use degrees, okay, or radians to measure the angles. Okay, so what's the relation between degrees and radians? Well, first, let me just give you some examples here. Examples. All right, so let's say this is your here's your vertex. All right, so if you go from let's say from this side to this one here, okay, so we have a right angle, right? This would be a right angle, and it's a counterclockwise, right? So it's a positive. So a right angle, of course, that would be 90 degrees, right? So this would be here, this would be 90 degrees, right? Now, if you go to the opposite side, so if you go from from this side to the opposite side, to this one here, okay, then that would be 180 degrees, right? This would be 180 degrees, right? Now, if you go to the, let's say, from this side to the here to the down here, all right, then that will be of course, so it's 90 degrees and 180 plus another 90 degrees, that will be 270 degrees, right? The screen is black. Uh,
I
does
don't know
anyone?
because I can't see it from my end. Or I'm gonna just go back and come back in again. I'll try it again.
Okay. Does anyone see the the board? Oh, okay. I'm not the same. I guess you have to refresh your page. Yeah.
Okay, okay,
You
yeah, I'll
see?
refresh
Okay.
it.
Okay. Perfect. Okay. Yeah. I'm sorry about that. All right, guys. Yeah. So I was saying. So now, if you do like a full, rotation, guys, then you would have 360 degrees, right? So if you do, if you start from this initial side, and then you end up. You see now? Okay. Perfect. Perfect. And then you end up with at the same side. All right, then that will be 360 degrees, right? So anyway, so these are just examples of possible angles. So you can have, of course, there's also zero angle. So zero angle would be just if your initial side and your terminal side is the same, then that will be the zero angle, right? So if you, let's say you have, this is this is your initial side, right? Initial side, and then your terminal side is the same. Coincide with the initial side. So your terminal side is the same as the initial side. So my terminal side is the same as the initial side, right? So if the initial and terminal sides they coincide, then that will be the angle zero, right? So that's the 0 degree. Okay, so this is if the initial side is equal to the terminal side. Okay, so that will be the angle 0. Okay, so that's angle 0. Okay, 0 degrees. Okay, guys. Anyway, yeah. So now, as I said, you can measure the angles using degrees or radians. Okay, so what's the relation between radians and degrees? So actually, 360 degrees. So a full rotation, that will be 2 pi radians, right? So relation between degrees and radians. Okay, so the thing is 2 pi, or let's say 360 degrees. So 360 degrees is equal to 2 pi radians. Okay. Or if you divide by 2, then 180 degrees. 180 degrees, that's pi radian. Okay, so this number pi is a very special number, right? Pi is it's 3.1415 something, right? So it's a very special number. But anyway, so this is a relation between the degrees and the radians. Now, how do we convert degrees to radians? Well, so if you have an angle in degrees, then you have to convert. So to convert from degrees to radians, you have to multiply by pi over 180. Okay, so you multiply by pi over 180. Okay, radians. And if you wanna convert an angle from radians to degrees, So to convert from radians to degrees, we have to multiply by the reciprocal. So you have to multiply by you have to multiply by 180 degrees over pi. Okay. So, for example, let's have a couple of examples. So examples. Example. So first example, let's say you have so example 1. So let's say you want to convert let's say 240 degrees to radians. Okay. So to convert from degrees to radians, just multiply by pi over 180 radians, right? So you have 240 times pi over 180. Okay, so that would be 240 over 180 times pi. Now the thing, guys, we have to reduce a fraction, right? This 240 over 180, so we have to reduce a fraction. So this is, you know, for example here, you can divide, let's say, both of them by 10. Is over 10, is over 10. So then that's 24 over 18 pi. I can still divide both of them by, let's say, by 2. So here's over 2, here's over 2. You know, so that's, let's say, 12 over 9 pi. I can still divide, let's say, I can still reduce a fraction. I can still divide by, let's say, by 3. So here's over 3, this is over 3. So then the answer would be 4 over 3 pi, or so 4 pi over 3. Okay, so you have to keep reducing your fraction, right? And so then that would be the answer. So that's how we convert degrees to radians. Okay, so multiply by pi over 180. Now the other way, if you want to convert radians to so this is so it's very important, guys, that you keep, so you have to reduce your fraction. So you have to reduce the fraction. Okay. Now from radians to degrees. So let's say you want to convert 5 pi over 6 to degrees. All right. So from radians to degrees, we said you have to multiply by 180 over pi, right? So so it's 5 pi over 6 times, and we said 180 over pi. So it's 180 over pi, right? The pi, of course, cancel out. This pi here in the top, there's the pi in the bottom. They cancel out, and then you're gonna have let's say 5 times 180 over 6. So that will be equal to well, it's 900 degrees over 6, and 900 degrees over 6, that's actually 150. So it's 150 degrees. Okay, and that will be fine answer. All right. So that's how we convert, let's say, radians to degrees, right? So you have to, of course, guys, you have to reduce your fraction or you have to simplify your fraction, okay? Okay, so here's an exercise just to convert some angles. So exercise. Okay, so first, let's say, so please try to convert. So first, let's start with from degrees to radians. So let's say you want to convert 300 degrees to radians. Okay, to, let's say you want to convert. So you want to convert 17 pi over 4 to degrees. Right? Okay, guys, so you have a couple of minutes to convert those angles. All right, guys. So what would be 300 degrees in radians? But Basir, 10 over 6, you can still reduce the 10 over 6, right? That will be 5 over 3. So that will be 5 over 3 pi. Mm-hmm. Yeah, so for the 300, so to go from degrees to radians, we said that we have to, so this is your 300, so you have 300 degrees, right? So we said we have to multiply, to go from degrees to radians, we have to multiply by pi over 180, right? So that's 300 over 180 times pi. Now the thing is, as I said, you have to reduce this fraction. You can divide first, let's say by 10. Here's over 10. Here's over 10. So that would be, let's say, 300. 30 over 80 pi. I can still reduce this fraction, so I'm gonna continue with the reduction. So I'm gonna divide here. Let's say both are divisible by, let's say, by 3. So here's my over 3, right? So that will be equal to 10 over, so 18 over 3, that's 6 pi. I can still reduce the 10 over 6, right? Both are even numbers. So I can, I can divide by 2, both of them. So that will be 5. So that's actually 5 over 3 pi. Okay, and so the answer would be 5 pi over 3. Okay, so yeah, so that's the 300 degrees. It's 5 pi over 3. Now for number 2, going from radians to degrees. So for number 2, so we said, so that's 17 pi over 4. So to go from radians to degrees, we have to multiply by 180 over pi, right? So then there's a pi in the top, there's a pi in the bottom. They cancel out. This pi here, they cancel out. And then there is, so we are left with 17 times 180 over 4. So now we have to do the computation, guys, right? So 17 times 180, it's actually 3060 over 4, right? And then you can reduce, you can divide 3060 by 4. So that would be equal to actually 765. So the answer would be 765 degrees. Okay, so 3060 over 4, that's 765 degrees. All right. Okay, so that's a relation between degrees and radians. Now, so I guess I can introduce the trig functions. Well, we have like 5 minutes left, but so I'm gonna try to do my best. So so here's trig functions. And of course, we'll continue with the trig functions on Wednesday. So I'm gonna start with the unit circle. So let's say we have a unit circle. So that's the circle of radius 1, right? So we have this. This is 1 here. This is -1. You know, you have your axis. This is -1. This is supposed to be your x-axis, and this is supposed to be your y-axis. And then you have your unit circle. So that's the circle of radius 1. So the circle of radius 1 passes through 1, 0, 0, 1. It's -1 here and -1 here. Okay. So this is your unit circle. So what do I mean by unit circle? That's the circle of radius 1. Radius 1. Okay. Anyway, guys, so in this unit circle, I'm gonna, let's say my initial side, I'm gonna take, let's say this side, this one here as initial side. Okay, so this is my initial side, right? Initial side. And then somewhere, let's say here, say here somewhere, that's my terminal side, right? This is, let's say this is my terminal side, right? So as I said, you go from the initial side to the terminal side, you get an angle. So here I'm gonna get some angle. So this is my angle theta. Right, this is my angle theta. All right. Now, and of course, there is very interesting point here. You know, if you take this terminal side, there's this point here on the unit circle. This point here, let's call this point. So this point has coordinates x and y, right? Anyway, so you have this angle theta, right? So let me just I'm gonna draw again this angle theta. So we have, there is this initial side here, and there is this terminal side. All right, and here's your angle theta. This is your theta. All right. Now, what's the definition of the? I'm gonna start, I guess, with the sine. So, sine is defined. Sine of the angle theta. So sine of the angle theta. So this is not sine times theta. This is sine of the angle theta, right? So, so a sine of the angle theta is supposed to be, by definition, right? This is a definition sine of theta. That's the opposite side over the hypotenuse. So we have this, you know, you have this right triangle here. This, you know, you take this side here, this right, you're gonna have this right angle here. Okay. So we have this right triangle, this one, yellow one. Okay. So by definition of the sine of theta, so sine of theta would be the opposite side over the hypotenuse, right? So what would be the opposite side to the angle theta? You know, this is supposed to be my angle theta, right? This is my angle theta, right? So then the opposite side to theta would be this. This side, right? This is the opposite side to the angle theta, right? This is the opposite side to the angle theta, all right? And then the hypotenuse of my right triangle would be this slide here, this one here. All right, that will be the hypotenuse. Okay. And so by definition, by definition, the sine of theta would be the opposite side over the hypotenuse. Now, for cosine of theta would be the adjacent side. So adjacent side over the hypotenuse. So what's the adjacent side to theta? Hypotenuse. Again, guys, this is your angle theta, right? This is your angle theta, right? So then the adjacent side would be this one here. Right? This would be the adjacent side to the angle theta. Okay. Anyway, I guess I don't have time actually to continue with this trig functions. I'm gonna stop here, guys. Okay, and next time I will continue with this trig functions. All right. So I guess I will see you on Wednesday, right? And again, tomorrow I will post a review sheet for the test number 2, and test number 2 is gonna be next. It's gonna be next Monday. All right. Okay, so I'm gonna stop here, guys. Well, thank you everyone, and I will see you on Wednesday. All right. Thank you. Take care.